Now let us assume that you are provided in your practical a program to search an element of array using linear search. So what are the possible questions that may arise is like this. First is define searching process. So searching is the process of finding an element within a list of elements stored in any order or randomly. So if certain elements are there, you need to find a value whether it is available here or not. Then this is called searching. So there'll be two results, whether you will find a value or you will not find a value. Two, how many types of searching are there? There are various types of searching, but basically two types of searching are there. First is linear search, then binary search. Linear search is also known as sequential search. 3. Define linear search. What do you mean by linear search? In a linear search, we access each element of an array or the values one by one sequentially. Means if we are searching this element, we will be searching the next element only. We will not go to any other place to search. We are bound to search always for the value in the next upcoming value, and we see whether it is a desired element or not. Question 4. Why binary search method is more efficient than linear search? Linear search. Why? Because it takes less time. Linear search means if your array is long or if your data structure is long in which you have stored the elements, then you have to start from the scratch, and it may possible that you will get the element in the beginning only. But there is a possibility that you will get the element which is located or placed at the last position of the array. Then what you're going to do? This will take an order of n. Okay, but when less time is concerned, linear time to search an element for a sorted list of elements, the binary search will do you a favor by just reducing the time to say log n. This is because only we search the half part every time. What is the efficiency of linear search? As we have just discussed, the time taken or number of comparisons made in searching a record in a search table, it determines the efficiency of the technique. And in linear search, the efficiency, because we always look for the worst case. So we are supposing that the element is placed at the last position of the array. So it has to traverse n, or the algorithm has to check for each and every value. So it has to make n comparisons. So the running time or the efficiency will be order of n. What do we understand by the term linear search is unsuccessful? This means that all elements we have accessed and the desired elements are not found. So I'll go back to the question number 5. What happens if the element is at the last position? But what happens, the second case, is when the element is not there at all. So every time we have to check for the element which is not there, we have to do the n comparisons. This is the problem. This is the efficiency loss here. What is worst case? What do you mean by worst case? In the worst case, the number of average case we may have to scan half of the size of the array, that is n by 2. That means this is just an example. I'll tell you what worst case is. Worst case is the case beyond which, if we say that the worst case is this, that case there will be no detrimental case beyond that worst case. That means if you want to linear search, then the only worst case could be the element is not there or the element is situated at the last. This is the worst case. What is the best case? It will be in the beginning. What is the average case? It is in between. What is the drawback of linear search? There is no requisite for the linear search. The drawback is you have to access it sequentially. This is the only thing which is the disadvantageous thing. And moreover, there is no requisite for the linear search. That is, during linear search, when the record is present in the first position, then how many comparisons are made? Only one comparison. During linear search, when the record is present in the last position, then how many comparisons are made? Again, we have seen this in the earlier questions also. We have to perform n comparisons. Now, if you are given a program in a practical that prove you have to reverse the element of an array and insertion and deletion on array at a specified position. So you have an array and you want to perform the reversing of this array. That means you want this element to start with this and likewise. the first element has to be the last element has to be first element, and all these needs to be shifted. All these numbers should be here. So there is a reversal of values. Also, you want to place a value in between. Now, in array, if you want to place a value, you have to make space for this value. For that, you have to right shift these value, you have to left shift this value. And if you want to delete some value, say here's an element, and you want to delete that element, then what you are going to do? If you want to delete it, then you have to because this space cannot remain blank. For that, what you have to do? You have to shift these values here to fill in the gap. So, what is an array? How many types of array is represented in memory? An array is a structured data type. It is a data type mixed up of finite fixed size collection of homogeneous ordered element. I'll not say ordered element actually, but still it is a fixed size. First is array is fixed size. Homogeneous elements means the likewise element, same domain. If the elements are integer, all elements will be integer. And this is a structured data type. And there can be number of types of array: one-dimensional, two-dimensional, multi-dimensional array. How can we declare an array? This is quite simple. First, you have to write the data type here, the variable name, then not the expression exactly, but like size minus 1 or something. But you have to give the size of the array. For example, if I write int a and I give size as 100. Okay. So this is what is the declaration means. By a semicolon. So this is the data type, this is the variable name, and this is what we have, the expression of the size. How can we insert an element in an array? Insertion of a new element in an array can be done in two ways. You can insert at the end of the array, or you can insert at required position. If you are required to add the value at the end, then that space should be there. The last element should be able to hold, or the size of the element of the array should not be causing some overflow kind of stuff. Insertion at required position, I told you, if you want to insert, it is also possible. You have to do some shifting. How can we delete an element in an array? So deleting an element at the end of an array presents no difficulty, but deleting an element somewhere in the middle of the array, that means some shifting is done. How many types of implementation of a dimensional array? When we talk about n-dimensional array, or say single dimensional array, that is 2D array, then not single dimensional, 2D array. I'll change my sentence to be 2D and more than that. So you can have a row major implementation, you can have a column major implementation. What are array of pointers? Now this is an array. Okay, this contains some values, but if these array positions contains the pointers, and pointers are nothing but the address of some value or address of some variable. So if these places are being taken by the pointers, that is the addresses of certain values, we call this as an array of pointers. So array of pointer refers to the homogeneous collection of pointer. Homogeneous, why? Because only integer pointer can be placed only if one is, you have to place a double, only double will be there. So that is a collection of pointer of same data type. What are limitations of array? First of all, array can only contain homogeneous data or homogeneous data type element. The size is also fixed. Insertion and deletion is quite expensive here. These are static structure. So first it is static. That means you cannot increase it. That is what I was saying. That is, it has fixed size and it is very time consuming to add and delete and etc. Where not to add and delete, but to insert and to delete in between. Where the elements of the array are stored respectively. Simple. Elements of the array are stored respectively in succession in the memory location, and these memory location has to be contiguous, means one by one. If this is 1000, if we have stored say integer, the other has to be 1004. The next one is to be 1008, and so on and so forth. How can you merge two arrays? The simplest way of merging two arrays is that to first copy all elements of an array in a third empty array and copy the elements of other array in the third array. So what this answer means is you have this one array, you have this second array. Now you want to place it, merge this. So what you can do is you can have an array at least, or the size should be at least more than the total size of these two arrays. Then you can copy this array here, and after this you can copy this array here, the values here. What is the operations of array? You can insert, delete, traverse, you can merge. These are the operations you can perform on an array. Then if you are given a program which is based on, say, structure or a union, then what questions can be asked? So what are structures? First of all, structures are used to store different data types. Structures are like we write as struct. This is how it is defined, struct. And then inside this you can have different types of data item. That is, you can have a name, that will be character or a string. Then you can have age, that will be maybe age is always an integer. Then you can have a salary, that can be double or a float. So you can have different data types inside. It is different from class. You might be asked about the class, since structure can only hold the data variables, but class can have variables also and functions that are operating on those functions. What are arrays? We have seen the arrays. They are the finite size homogeneous data type containing contiguous memory locations. So arrays are used to store similar data types. Is array of structures possible? Can you have an array in which you can store structure? The answer is the array of structures are possible. Okay, we cancel this. The array of structures are possible. And this is a very useful possibility which is implemented and used at various places. How structures are declared? This is how we declare the structure. We write struct, the name of the structure. Then you can have a character name, float, and int. So you have a possibility of having different data type item or declaration inside a single structure. Why we use functions? First is that you want everywhere. If you want to perform some work, say you want to organize an event, so what you do? You say catering will be given to you, and the say songs or the arrangement of the desk or dais and the arrangement of transport. So these works are assigned to different people, different say committees. So this makes your work easier. That is how, if a program is there, then the different tasks can be performed by that program. So these are the functions which make this event possible. So functions are the functions which are doing some work for the main function. And these functions, they also avoid rewriting the same code over and over again. You don't need to place those lines again and again. You just have to call the function wherever it is required. Name some library functions. Printfs they are all library functions in terms of C language, and C out, C in, all these are in you can have it in C++ and likewise. What are user defined functions? Those functions which you define, which are not library functions. So these are declared by the user. These are called user defined functions. What is call by value? When the value is passed in the function, it is called call by value. Actually, the call by value is it sends the copy of the value. The more exact answer would be it will send the copy of the value, not the actual value. While in call by reference, these two methods are the way in which we send the values to the formal parameters. The actual parameters are sent to the formal parameters of the function. Call by reference is when the value is passed. Here we pass the value. Here we pass the reference or the address. So we are actually in a way logically sending the actual value only, because we are sending the address and the address contains that value. So if the address is sent, any change which is done on that particular address will be reflected in the value which is stored in that particular address only. Why we used keyword break, or why we want to use this keyword break? When you want to come out of the loop, this control automatically passes to the first statement after the loop. So break is a kind of a keyword which enable us to come out of the loop, because loop goes on and on, but sometimes you don't want them say for you want to run a for loop from I to 1 to 10. Now you don't want the computation to be done for 5, so we say if 5 then continue. But if you say that it comes some other value, you just break. Now we have a program which can be given to you, that is a program to implement push and pop operations on stack. So first question can be, what is a stack? Stack is an ordered collection of elements, just like an array. Just like an array, a stack is nothing but an ordered collection of elements. So what are the operations that can be performed on stack? We can push and pop. So we can push for insertion and we can pop for deletion of an element. And the stack is like this. It is a data structure in which you can place a value. It will be stored here. You can again place a value here. And now you want to remove this value. So the latest value which has been fed or been placed will be retrieved. So that is this stack follow last in first out model. What is push operation? When an element is inserted into the stack here, this is called as push operation. What is pop operation? The values are placed here. Now you want to take the value out. That is the pop operation. So when you want to delete an item from the stack, it's called a pop operation. How can you implement a stack? A stack can be implemented in two ways. You can have a static implementation. For that you use array. You can have a dynamic implementation. For that you use the pointers. What are the applications of stack? Say infix, postfix, and prefix notations. They are applications of stack. Even the recursion, in this we use heavily the stack. So stack is an important part of any computation. What is recursion then? Recursion is defined as a function which is calling itself. A function calling itself is a recursion. One more theory can be dividing the function or the task into subtasks so that finally the end value or the last value can be employed by calling the function itself or calling the subprograms or subproblems. What are the different types of stack? There are two types of stack. One is direct, the other is indirect. So a system calls itself from within itself, that is direct stack, and two functions mutually call one another. This is indirect one. Define the top of the stack. Every stack has a stack pointer which points to the topmost element of the array or say a stack. So this is the top of stack, a pointer indicating the top element of the stack. Is stack primitive or non-primitive data structure? Actually, it is a non-primitive data structure. That is why it is implemented by using array or pointers. Now you may be given a question in your practicals that you have a program which is based on infix to prefix or postfix notation. So what is a stack again? We'll come again to stack. This is an ordered collection of elements like arrays. It has a special feature that deletion insertion of the element can only be done only on the top, which is called the top of the stack. This is called as, it is also known as LIFO, last in first out. Application of stack, we have seen infix, prefix, postfix, and others also. Term used in stack, for that we use context, stack frames, max size, min size, and st pointer like this. This depends on the implementation actually. Explain infix in stack. The operation is written in between the operands. So a plus b, this is infix. What is postfix? The operand is written after the operands, ab plus. It is also called the suffix notation. Define operations of stack. You can perform push and pop. You want to place an element, you do push. You want to take out an element, you do pop. Give postfix form of a, b, star, c2. So that will be postfix. Okay. So how we are going to do this? First we'll write star. Then we do this ab plus, and then we do cd divide. So this is how it is done. But here we, in this particular case, what we do, we perform AB plus first. That is AB and after this plus. Then what we do, C into D. So C into D has to be there. And then we divide them. Okay? Because divide and star, they don't have a multiplication, they don't have any brackets here. So for that, we have to consider the precedence of the operator. For that, what we are going to use, we'll do C star D means multiplication first, then this will come. So this will take the precedence. Give the postfix forms for this. I hope you are able to do it. A, B plus, and then divide, and C, D minus. Okay. First we do divide, then we plus, then we minus. These are the operator precedence. Give the prefix form of A by B and then exponential C plus D. That will be nothing but plus slash A exponential or DC. This is important. And then D. So these were a few questions and answers on the type of programs which can be given to you in the practical or Viva sessions. Thank you so much. Take care.